All right, today we are jumping headfirst into the world of real-world data. You know, the messy, wild stuff that every analyst has to deal with. And our main tool for this adventure? It's one of Python's most powerful libraries, Pandas. So let's get right into it.
You know, if you've ever actually worked with data, you know the deal. It's almost never that clean, perfect data set you see in textbooks, right? Nope. Real-world data is messy. It's got missing parts, weird formatting, it's just chaotic. So the big question is, how do we take that chaos and turn it into something we can actually work with?
Well, the answer is a tool that's going to feel pretty familiar, but trust me, it's way, way more powerful. What we're talking about is the Pandas data frame. And honestly, the best way to think about it is like a spreadsheet on steroids. But here's the kicker. It's a spreadsheet that you control entirely with code.
So this is where you really have to shift your thinking. You know, with the regular spreadsheet, everything is manual. You're clicking, you're dragging, and you're pretty much limited by what you can see on your screen. But with a data frame, everything is code. It's all automated. It can handle millions of rows, no problem. And this is the real game changer. It's perfectly repeatable. Just imagine running this super complex multi-step cleaning process on new data like instantly, just by running one script. That's the power we're talking about.
Okay, time to put on our data detective hats. The very first step in any investigation, right? You gotta open the case file. For us, that means loading our raw data from a file right into our programming environment.
And the magic key to unlock this case file is a really simple but super powerful command. pandas.read_CSV. CSV just stands for comma-separated values. It's a super common universal format for data tables. And believe it or not, this one little function is all it takes to get our evidence loaded up into Pandas.
So here it is, our students.csv case file. At first glance, it looks pretty straightforward, doesn't it? But if you look a little closer, you'll see Priya is missing a mark, and we don't know what city Sanjay is in. Pandas flags these missing pieces as NaN, which just means not a number. And right there, those are our very first clues that this investigation is just getting started.
Okay, so our data is loaded. Now, a good detective doesn't just rush in and start asking questions, right? No. First, you do some surveillance. You got to get the lay of the land and just see what this data set is really all about. Our very first tool for this is head.head. And it's exactly what it sounds like. It just gives you a quick peek at the first few rows of your data. It's a super simple, instant way to just check, hey, did everything load correctly? And to get a look at our column names. All right, next up, we use info to get a more technical summary. This command gives us a whole rundown. Every column, how many non-empty values are in each one, and, this is really important, the data type. This is absolutely crucial because it's how you'd spot a huge problem, like a column full of numbers that got accidentally read in as text.
And for a quick statistical profile of our suspects, our data, we use .describe. It's amazing. With just this one command, you get the whole story for all your number-based columns. The count, the average, the standard deviation, the minimum, the maximum, it's all there. A complete statistical summary instantly.
So our little surveillance mission with .info already gave us a big tip-off, right? The counts for each column didn't quite match. So now it's time to zoom in on that. We need to systematically find every single one of these missing clues.
And the tool for this job is this beautiful little two-part command, .isNay.sum. So here's how it works. First, .isNay goes through your whole data set and basically marks every empty cell as true. Then .sum comes along and just adds up all those trues for each column. And what do you get? A perfect, clean count of every single missing value. And when you visualize that result, well, the problem becomes crystal clear. The name column is totally fine, but we're definitely missing one mark and one city. Okay, our problem is now officially defined. Okay, so finding the missing clues, that's half the battle. But now comes the important part. We have to decide what to do about them. And in our data detective toolkit, we've got two main strategies for dealing with these empty cells. So here are our two go-to tactics. On the one hand, you've got drop NA, which is basically the remove it strategy. It's the simplest thing you can do. If a row has any missing data, poof, the whole row is gone. It's super fast, but you lose data. On the other hand, you have fill NA, the replace it strategy. Here, instead of deleting, we fill that empty spot with a value that we pick. This keeps the row, but it does mean we're making a bit of an assumption.
Now, drop NA is often a great choice when you've got a huge data set and just a few missing values scattered around. I mean, if losing a tiny percentage of your data isn't going to mess up your analysis, it's a really clean and simple fix. And you get some control too. You can tell it to drop a row if any value is missing or only if all of the values are missing.
Fill NA, on the other hand, is what you'll want to use when every single row of data is precious and you can't afford to lose any. Its real strength is how flexible it is. You could replace a missing test score with a 0, for example, or a missing city with a placeholder like unknown. The point is, you get to keep the whole record, and you're just filling in the blanks.
All right, let's just take a step back and look at the whole workflow we've just built. We've successfully gone from a raw, messy case file to a nice, clean dataset. And we did it by following a really clear and, most importantly, repeatable process.
And this 4-step process, this is really the backbone of so much data cleaning. Step 1, load the case file with read CSV. Step 2, do your initial surveillance with .head and .info. Step 3, find all the missing clues with .isNot.sum. And finally, Step 4, fix the problem, choosing between drop NA or fill NA.
So there you have it. You've now officially cracked the case of missing values, which is honestly one of the most common problems you'll find in messy data. But, as any good detective will tell you, closing one case usually just opens up another one. So what happens when you find duplicate records, or typos, or numbers that just don't make any sense? Well, that's your next investigation.